Go through a bunch of different ways to describe these functions, starting out with some nice. Let's come back together, folks. Thank you. So we're going to talk about how to describe some functions here, the number of different ways. Let's start off with something nice and familiar to us, and that is with the description proportional. We've spent what seems like far too long talking about proportional and non-proportional equations. Now we're just going to put it in the frame of functions, which is pretty much the same thing. Y equals mx plus b is a function. So proportional, obviously, as we know, it's going to look something like this. Anyone remember the two conditions that need to be met in order for a line to be considered proportional? Yes, linear and goes through the origin. Great job. Linear through the origin. What does linear mean again? Straight. So if it's a straight line that goes through the origin, it's proportional. Nothing new there. Good little review. Something to keep in mind at the end of term 2, right before our winter break. We're going to have a nice, long final exam covering everything we've learned since August 13th. All right?
That's when you start school?
Something like that. So all those exponent rules, scientific notation, proportional, non-proportional, all that good stuff. We're going to test on all of it because we didn't have a final in term 1. So we're rolling it over to term 2. So proportional is how we're going to start. Your 7, what is that, C? Yeah, 7C. Yeah. Proportional, straight line through the origin. Like I said, nothing new. We're just starting notes right now, okay? Thank you. You're in 8B, next to Nellie right there in the pink. Give me 2 seconds. Why did I lose this thing? Okay. Of course, the opposite of proportional would be non-proportional. Very similar to our proportional graph with one key difference. Anyone notice the key difference there between those two? Yeah, Devin, what's the difference?
The proportional, it goes to the origin, but the non-proportional, it doesn't go to the origin.
Exactly, that's the only difference. Proportional goes through the origin, non-proportional does not go through the origin. And something new that we're going to add to this is that non-proportional can be linear or not. Non-proportional functions do not have to be a straight line. We'll see kind of what that looks like in a second. But we also know that they do not go through the origin. So some quick little equation examples. For proportional, we could have y is equal to 2x. Y is equal to negative 1/2 x. For my non-proportional functions, we could have something like y is equal to 2x plus 1. Or y is equal to negative 1/2 x plus 4. Again, the key difference is our b value. Proportional equations have a b value of what? Anyone know? What are we adding on to the end of these equations?
1.
Do you see a 1 there?
Oh, X.
X?
So b is where we cross the y-axis. At what point is that right there? 0. Let's add that in here. B is equal to 0. For non-proportional, we see that we've got plus 1 and plus 4. So b will not be equal to 0. Zoom in here just a little bit so we can see better. And there's our difference between proportional and non-proportional. It's easy to get fooled, especially with the graphs, but I trust you guys know about that origin by now. We spent a lot of time talking about it. So after proportional and non-proportional, how else can we describe a function? Well, we can either describe it as linear or nonlinear. This is going to be kind of our first introduction to nonlinear graphs. Everything we've done up to this point has been a nice straight line. Now we're going to switch it up. So a linear function, as we know, is going to look something like this. We can characterize this as being a straight line, of course. That's if we're looking at a graph. If we're looking at an equation, we can tell if it's linear or not if there is no exponents in the equation. I'm going to move this down so we can focus on linear and nonlinear. So as a graph, linear functions appear as straight lines, but if we're looking at the equation of a line, we got to make sure we have no exponents in that equation. So no x squared, no x to the thirds, nothing like that. So our equations would look something like y is equal to 3x minus 2. Definitely no exponents there in that equation. Bless you. Or we might just have something like y equals 4. Bless you. Y equals 4 would be a... No, y equals 4 would be a horizontal line because the slope is 0. We didn't spend a whole lot of time talking about that, but we kind of did. But yeah, we did. We had a whole lesson on undefined and 0 slope. Talked about the treadmill and the mountains.
Oh yeah, we did.
Remember what I'm talking about?
Yeah.
Yeah. So y equals 4 would be like a horizontal line with a y-intercept up here at 4. It would just be flat line like that. Which is linear, straight line. Flat line is a straight line. Now, non-linear is going to look something like this. Let's see.
Not a straight line.
That's right, it's going to be a not straight line. Now, there's a bunch of different ways that we could kind of showcase what a nonlinear function looks like. But the way that we're actually going to be graphing in this unit is something that looks like this.
A U.
It's a U. Anyone know what we call that U-shaped line? I'll give you a hint. It does not start with a U.
What does it start with?
It starts with a P.
Proportional?
Proportional. Good guess. You're on the right track.
Isn't it a state or something?
A state? Pennsylvania?
No. Utah.
Hey, I'm just
I put it in the notes yesterday.
No,
Let's
you
see.
didn't. No, you
You
didn't.
put something in the notes.
A pear?
No. What did I put in the notes yesterday?
No, you didn't.
I don't think you guys would even know the name.
Wait, say it.
You're closer. Parabola. Does that sound familiar to anyone?
No.
Good. It shouldn't sound familiar. You have not learned this yet. That's why I wanted to see how far you guys would go to guess, because I knew you didn't know the word, because it's a weird word. This is called a parabola, or as most people start out calling it, a parabola, because that's how it's spelled. Parabola, parabola. It's just a U-shaped graph. Now, it could be a U facing up, it could be a U facing down, a U facing left, or a U facing right. But it's always going to look like a curve like this. So we know that nonlinear functions are, of course, not a straight line. Does this look like a straight line to you?
No.
Nope. It's a curved line. So it's not a straight line. And there's going to be at least one exponent in our equation for this line. Now again, this is going to be a brand new idea for us, which I love. A lot of this stuff is kind of review from last year, except for this. So some nonlinear equations might look something like this. For example, we could have y is equal to x squared. We have at least one exponent in our equation. We know right away that it is nonlinear. We could also have something like y is equal to 3x squared plus 1. Notice how it's still in our Yo Mama's Ex-Boyfriend format. Y is equal to m. My slope would be 3x plus b. But now the only difference is our x is being squared. If I were to expand x squared, what would that look like? You remember from our first unit? 2? It would be 2 of something. 2 x's, right? X squared is x times x. A lot of times we look at x squared and think, oh, it's x times 2. So if my x is 4, then my answer is going to be 8. But no, x squared is x times x. X times itself 2 times. So if my x is 4, 4 squared would be 4 times 4, 16. We'll review all that in a little bit, don't worry. By a little bit, I mean next week or this week. Not today. But that's what our nonlinear equations look like. So when we square that x, it does something really weird with our line where it kind of bends it in a certain way. And we'll see why that's the case tomorrow. So those are 4 ways for us to describe our functions: proportional, non-proportional, linear, and nonlinear. In order to prepare us for our assignment today, again, this is one of those lessons where can't really put it on a worksheet. We'll get our first yellow worksheet of the unit tomorrow. Let's just take a look at what some functions will look like and what some non-functions will look like. Let's start off, of course, with functions. Go ahead and draw 4 little coordinate planes here. Just like that. Oops. We're going to look at 4 interesting looking functions. Going to be some weird looking graphs. It'll be all right. Keep looking at what we're doing. Good. Good. Graphs don't have to be perfect. We're going for the actual shape of the line here, not necessarily all the coordinates and all that. So my first function, like we noticed, is a parabola. Looks like that. This is a function. Is it a linear function?
No.
No, because it's not a straight line. But it's still a function. We could also have a function that looks like this.
Like an N?
Like an N. Or kind of like 2 parabolas holding hands.
What?
Except one's upside down. But that's definitely a function as well. It's called this is like 3 years from now you'll learn about this. This is called a sine function. Actually, this one I think is a cosine function. Don't worry about that. But still a function. We could also have something like that. Looks like a, anyone watch American Ninja Warrior?
Yes.
Yes.
Looks like the warped wall, kind of.
Oh, yeah.
Or like
What
a
if-
skate ramp.
Yeah.
Yeah. Which is basically the same thing from American Ninja Warrior.
It's like when you run up and touch the phone.
Yeah. It's like the curved wall you gotta
It's a
run up.
ramp, basically.
Yeah, it's like a ramp.
Basically.
This is called an exponential function. Again, you won't need to worry about that until you're like 17 or something.
Jeez.
So in high school.
Yeah, so in high school.
30-year high school.
I'm not teaching you all that. That'll be your high school teacher's job. And we could have something like this. Just an absolute value function.
It looks a triangle.
It looks like a V or a pyramid or a triangle without a bottom. Now you may be wondering, how do I graph these? How do I plot these points? Good news, it doesn't matter. What we do need to know is that anything that looks like this is a function. Simple enough, right? Yes, no, maybe?
Yeah.
Let's take a look at what non-functions will look like, because this is where it might get a little bit tricky. Not a function. Go ahead and draw 4 more little coordinate planes.
I was set in here to like take my quiz.
Okay, come over here. didn't even see you walk in.
Oh,
Who's your teacher?
Miss Karam.
Okay, that's fine. Yeah, just take a seat. So those are our 4 functions up there on the top. Let's take a look at what would not be a function, starting with this. What does that look like? Smiley face, yeah. A sideways smiley face. Looks like a C. Or looks like a parabola on its side. This parabola is a function. This parabola is not a function. Let's take a look at what else is not a function.
That's like a backwards 2.
Backwards.
That's a frontwards 2.
Oh. It just.
Or a backwards S, I think is what you meant.
Yeah.
Or a Z, right? Any of those things.
It looks like an S.
So this little squiggly N here is a function. This little squiggly backwards 2 is not a function. Are you starting to see kind of what we're doing here? These look, I mean, to the untrained eye, these look like the exact same thing pretty much, right? Except one is a function, one is not. Your entire IXL today is going to be determining which ones are and which ones aren't. We'll find out how to do that in a second. The next one we've got, nice and easy.
A circle.
That is a circle or an O.
That looks like a sign.
That circle is not a function.
It's just a regular circle.
It's just a regular circle. And finally, if we have something like this, that is not a function either.
Are those things that they use in math? I don't know what they're called.
That's right. It looks like the little greater than sign, right? The crocodile eats the bigger number. It's like a 3rd grade throwback.
Yeah.
Oh man. Don't remember.
So take a look. The purple graphs are functions. The green graphs are not functions. Anyone notice the difference? What makes something not a function, Devin?
Most of them look sideways for some reason.
Most of them look sideways. That's a great observation. I love it. What happens when those graphs go sideways?
It's not functional.
It's not functional. Okay, good. Yes. Why not, though?
Because it's sideways.
Because it's sideways. All right, we're talking in circles. Let's figure out how we know when it's a function and when it's not with your ID card.
Oh, I lost that.
Go ahead and take out your ID card. Everyone's got one.
I left mine at home.
You got 2 of them. Didn't you? You left them both at home?
Well, my mom has mine.
You got something like a straight edge?
Wait, let me just see.
That's it.
Yeah.
I mean, I barely. I mean, there's not even a long sheet.
D and D. Boom. Why don't you want to use your ID card? We're not even going to draw anything. We're not drawing lines. If you haven't noticed, these lines aren't very straight. Stop. So, we're going to be doing something called a vertical line test. Everybody say that out loud. Vertical line test.
Vertical line test.
Vertical line test. This is something you're going to hear a lot about. Oh, you only had to say it once. So this is something you're going to hear over the next couple of years. And this is a way for us to figure out if we have a function or not. Let's start with the ones that are functions. We're going to take our vertical line. We're going to put it on the leftmost side of our graph. And what we're going to do is we're going to drag this vertical line from the left to the right. Okay, from the left side of our graph We're just going to drag it from left to right across our function. What we're looking for is 2 points that are stacked on top of each other like we talked about yesterday. We're looking for, this is our little graph, 2 points that are directly on top of each other. Remember in our IXL we saw that if there's 2 points on the same vertical line, it's not a function. So that's what we're looking for here. If we start off with this first parabola, are there any points where we have 2 of the same point stacked on top of each other? No. We can go across this entire parabola. There's only 1 point, 1 point, 1 point on the line, 1 point on the line, 1 point on the line. If we go down to this green parabola, though, we start on the left, we drag it to the right. Oh, look at that. I've got a point right there, and I've got a point right there. Those 2 points fall on the same vertical line, which makes this not a function. If you want, yes.
So if it has a straight line, it's not a function.
If there's 2 points that form a straight vertical line, it is not a function. That's right. That's all it is. Seems too easy. If we go back to this little squiggly one, the second one, as we're going across, we see, okay, 1 point, 1 point, 1 point, 1, 1, 1. I don't see any spots on this line where we have 2 points directly in line with each other. But if we go down to this squiggly line, oh, there I go. I've got a point right there. I've got a point right there. I've got a point right there. There's 3 points on this function that fall onto the same vertical line. That means it is not a function. Let's look up to this little skate ramp. If we drag from left to right, we've only got 1 point, 1 point, 1 point, 1 point. Yep, there's no places where my points cross. Down here with this circle, obviously, we've got point right there, point right there. Those 2 points are on the same vertical line. That circle is not a function. Bless you. Last purple one on the top, this little upside down V. Again, from left to right, we don't see any point on this lavender line where 2 points have the same x coordinate. None of those points are stacked on top of each other. But when we flip it sideways, we notice, hey, there are 2 points stacked on top of each other, which makes this one not a function. So let's say these 4 lines fail the vertical line test. Therefore, they are not functions. Someone turn the music down.
What?
Someone in the back's got their music down. Questions I can answer about that? All right, that's what you're going to be doing with your IXL. It's going to be BB2.